Good afternoon. Welcome to this lesson on hybrid vehicles. So we start by asking ourselves, what are hybrid vehicles? So a hybrid vehicle is any vehicle that combines two or more sources of power. Now, a good example is the diesel electric. Now, the diesel electric train has a diesel powered engine which then generates or drives a generator. The generator generates electric current, which then drives a motor. Or we have a nuclear electric, for example, the submarines. Or you can have even a moped. A moped is that bicycle that has an engine. So you can drive the bicycle by your feet, or when you're tired, you can switch over to the engine. Or even sometimes you can use both. Now, the most common form of hybrid or that we want to talk about today is a gasoline electric. And this gasoline electric is the one that we use a gasoline powered engine that can then drive a motor, and we can use the two or more sources of power either together or singly as demanded by the vehicle. Now, there are several components that make up a hybrid system, and among them is the engine, the fuel tank, the electric motor, the generator, batteries, and the transmission. When you look at the engine of the hybrid car is a conventional internal combustion engine. The engine assembly is used in this case, is actually smaller in construction and output, but it will always give us more than sufficient power, meet the emission standards required for today's world. We're really talking about uh, greening the environment. So if you look at various hybrid vehicles, they will have a small output engine like a 1300 C capacity, again depending on the size of the vehicle. Now the fuel tank, again on this kind of vehicles, is a conventional fuel tank. Only that it is smaller in capacity because it carries a less amount of fuel. Since these vehicles are fuel efficient, then you do not require a large amount of fuel. For example, where you'd have a capacity or a normal capacity vehicle having a tank of 40 liters, when used as a hybrid, the capacity of the fuel tank can be reduced up to 20 liters, and then some of that space is actually occupied by the battery storage. So this is because that the energy density of petrol is much higher than that of batteries. And that is to mean that 20 liters of petrol might weigh about 15 kilos. And the 20 liters of petrol can give you a range of about 400 kilometers, as opposed to the same weight of batteries at 20 kilos might only give you a range of about 50 or 100 kilometers. And that is actually the biggest downside of the hybrid vehicles. Now, the electric motors are the other component of the hybrid vehicles. Hybrid cars will use very sophisticated electrical motors to drive the powertrain. Now, these electrical motors are controlled by an advanced electronic control system that is not only used to design or that is not only used to drive this motor as a motor alone, but can also be used to reverse the motor to become a generator. For example, when the vehicle is decelerating or braking. So when the vehicle demands more power, the same motor can be actuated to assist the engine push or to pull the vehicle up a hill. Also, the same motor can be used again to retard the vehicle. And while it's being used to retard the vehicle, the motor actually generates battery power or energy that can be stored in the battery. Then we have the generator, and the generator is very similar to the design of the electric motor. And the concept that is used on the hybrid variants will provide electric power to the powertrain and to power the battery. So if you look at this image here, you will see we have several windings about or coupled to the bell housing, whereas the armature itself is driven together with the torque converter. So this assembly is actually hidden, that you will not see it unless you take apart this kind of concentric arrangement. And this makes it very compact, whereas we also get a very high capacity motor, which can also be used as a generator when the vehicle is returning. The batteries used for hybrid vehicles have changed over a period of time. Previously, we've had batteries that were used that were quite heavy and large, and they would occupy a large space. However, in recent times, we have advanced electronic control systems that now maximize the outputs of these units. So both the motors and the generators are optimized. And then we use lithium ion batteries that have a great lifespan. These are the same kind of batteries that you find on your cell phones. And these batteries actually have large charging times or reduce the charging times and can take on and give up large amounts of charge depending on the driver's demands and the drive cycle conditions. Lastly, we talk about the transmission. So the hybrid vehicles will use a conventional transmission assembly to provide the basic gear functionality. But in recent times, we have seen the use of constantly variable transmissions, or what we call the CVT, or the use of electric motors to transmit the drive directly to the road wheels. So here we have conventional transmission, which has a unique kind of clutch that is used to couple the drivetrain to the engine and to the motor. Now, there are several structures that come up with a hybrid. By structure, we mean how we arrange these two power sources that we find in the hybrid vehicles. So we can either arrange them in parallel, in a parallel arrangement, or a series arrangement. Either one of these arrangements will allow the gasoline engine to shut down when it is not needed. Now let us look at the parallel system. In the parallel, both the internal combustion engine and the electric motor are connected to the transmission and can individually or jointly drive the wheels. So the vehicle will either operate on the internal combustion engine, the electric motor, or a combination of both. So if you look at this arrangement here, you can see the final drive here together with the axles and the wheels. And then in orange here, we have the motor. So the motor can either be coupled to the engine on one side, and the engine receives its energy through fuel from a reservoir, what we call a tank. Whilst on the other side, the orange one is the transmission, the transmission can be coupled to the engine on one side. While on the other side, the same transmission can be coupled to an electric motor. The electric motor gets its energy from a battery through a converter or an inverter if you wish. This is simply because the battery stores energy in form of DC or direct current, and to drive the motor we require alternative current. So we call it this an inverter because it can work in both ways. When you're drawing power from the battery to the motor, we invert it to become AC. Whereas when you're using this motor as a generator, we convert it again to become DC. So you see this arrangement here, it means that the engine can drive the transmission, and while it's driving the transmission, it is actually driving the motor to become a generator and therefore store power in the battery. Once the batteries are filled up with energy, then the engine can shut off, and then we can draw energy from the battery through the converter to the electric motor and the transmission and to drive the vehicle. In instances where we require higher power demand, say you want to accelerate hard or overtake a vehicle, the engine can be switched on at an instant, and both the motor and the engine can be used to power the vehicle to give us that extra energy. When you're driving the vehicle in the cruising mode, speeds up to 80 kilometers per hour, then we cannot draw power from the battery to drive the motor unless we drain the power from the battery. Now, a series hybrid, on the other hand, will use the same internal combustion engine, but the internal combustion engine is not coupled to the transmission directly. The engine will solely be used to generate electricity. The electricity is then used to power an electric motor, which will then drive the wheels. So If you look at this image here, you can see that the engine is at the farthest end, receiving fuel from the reservoir. Then to drive the generator then uses a charger to charge the batteries. On the flywheel, we also have a capacitor that stores up some energy. Now, to drive the motor, we can either use power coming from the generator directly to drive the electric motor through a converter, or while at the same time charging the battery. Once the battery is filled up, we can switch off the engine and then draw power from the battery through the converter and to the electric motor. Nowadays, we have seen a new type of hybrids that were called plug-in hybrids, or the PHEVs. These are hybrids that have a larger battery pack that can be charged by plugging in to an external power source. For example, if you have a plug-in hybrid, once you drive the vehicle throughout the day and you park it in your compound, you can plug it into a power source and have these large capacity batteries charging up, so that anytime you want to move out, you can use the vehicle in only electric only mode for a certain range before the internal combustion engine kicks in to provide extended range capabilities as compared to both the parallel and the series hybrids. So now, if you compare the electric and the hybrid vehicle configurations, you see that the purely electric only has a battery, an inverter, and a motor. And the same motor can be used to decelerate the vehicle by what we call regenerative braking, and then the power goes through the inverter again to store charge in the battery. So the pure electrics require an external power source to store electricity in the battery. On the other hand, we have the series hybrid. And the series hybrid has the battery being charged by the engine through a generator. And then once the battery is charged up, then power flows to the motor through the inverter. And the same motor can be used through regenerative braking to store up some charge back to the battery. Lastly, we have the parallel hybrid here, which has again the engine coupled to the gearbox. And as the gearbox revolves, it drives the motor, which also acts as a generator. Now, when the engine is driving the gearbox, it is also driving the generator to store power in the battery. Once the battery reaches its maximum capacity, then the engine is switched off, and the same generator now converts to become a motor, and current draws from the battery through the inverter and to drive the motor and then the wheels. So the hybrid vehicles have several features that are included for optimization of energy. One of them being regenerative braking, and this captures the energy during braking and stores it in the battery for later use. So this to mean that the same motor you are using to drive the wheels can be used as a generator, and it more or less acts like an eddy current retarder, because when the armature is being driven in a magnetic field, it has a lot of drag and it is used to slow down the vehicle, and that energy is now stored up in the battery to be used at a later time. That means that you're also conserving energy. Also, we have improved aerodynamics to reduce the coefficient of drag of the vehicle. You notice that most hybrid vehicles have a slick shape that is able to cut through the wind and reduce the kind of drag created by forcing through wind. This means that these vehicles require less energy to move through the air, and therefore they can be able to save on energy. Hybrid vehicles will also have start and stop features that allow the engine to be switched off in traffic and when the vehicle is stationary for a period of more than 2 minutes. So if you're driving this vehicle and you stop in traffic for a period of time, the engine switches off, and also it switches off all power consumption, until when you move your foot from the brake pedal and step on the accelerator pedal is when either the motor or the engine comes to life. And this means that you do not waste energy in traffic, like you have the gasoline engine running in traffic awaiting for vehicles to start moving. The other feature is that they try to keep the minimum or the overall weight of a vehicle to a minimum. That means that all the components that make up the hybrid vehicles are engineered to be strong and light. Even if it involves the use of engineered materials like the carbon fibers, the titanium alloys, and so on, just to keep the vehicle stiff enough and also reduce the minimum weight. That means that if you have a less weight of a vehicle, you require less energy to move it, and therefore reduce the amount of fuel used. And lastly, hybrid vehicles have been known to use specialized stiffer tires that are inflated hard. And when you have a smaller patch of a tire in contact with the road, it means that you have minimized the drag created by the tire as it is being pushed onto the road. Lastly, we compare the advantages of hybrid engines or hybrid vehicles. One, they have improved fuel efficiency because they consume less. Secondly, we have reduced emissions because these vehicles run efficiently. The engine is only used to drive the vehicle when needed, and we have a smaller capacity engine, meaning that it is consuming less fuel, and therefore we also emit less emissions. Thirdly, is that we have potentially lower operating costs as compared to conventional gasoline-powered engines. Hands down, it is proven that hybrid vehicles will give you a fuel range of up to probably 50 to 40% more than the conventional gasoline engine. So where you have a 1300 capacity engine giving you a range of 15 to 17 kilometers to the liter, the same hybrid vehicle would give, if the same engine is used on a hybrid vehicle, it can give you a range of 20 to 25 kilometers to the liter. All these advantages are achieved by the benefits of leveraging the strength of both the internal combustion engine and the electric motors, such as the high energy density of gasoline and the efficiency and instant torque delivery of electric motors. So that brings me to the end of this discussion. Thank you for listening.